So after discussing these pro-competitive reasons, motivations for instance, for vertical integration or for vertical restraints, let's now move to potential anti-competitive concerns. So in particular, what we're going to focus on is the idea of foreclosure. So at first, when looking at vertical mergers, regulators or antitrust authorities were fairly reserved by the notion of having vertical mergers, so were reluctant to allow these mergers. And the reason why this was in particular when there was a monopoly somewhere in this supply chain, there was a fear of leverage of the monopoly power of that company. So the idea, for instance, might be if there's an industry which has an upstream monopoly, but where the downstream sector is fairly competitive, so it might be, for instance, many different retailers competing with each other, regulators or antitrust authorities would be typically have been fairly reluctant to actually allow this upstream monopolist to merge actually with one of the downstream retailers. And the idea here was, well, now this downstream industry is competitive, but if we allow this upstream monopolist to merge into this downstream sector, then we might create an additional monopoly position there, and that will be detrimental. So the fear here is going to be leverage of the monopoly power that already existed upstream to the downstream sector. So to look at this in this particular picture, so here is the supplier, the upstream supplier, who is the monopolist. Downstream, we have two competing retailers. Now, what will happen if this supplier, this monopolist upstream supplier, is going to integrate with this retailer, downstream retailer number one? Well, the fear here might be that this supplier is then no longer going to supply the goods to retailer two, thus destroying also the competition that already existed downstream. So that sounds fair, right? So you don't want the monopoly power that exists upstream to also be exported in a way to this downstream sector. So that was the idea, but this idea was actually challenged. So it was challenged particularly in the 1960s and the 1970s by economists and also lawyers from the University of Chicago. And they are actually called the Chicago School. So this critique that they gave is by now sort of known as the Chicago School critique. And they said, well, wait a minute, this is actually not so obvious that you can actually leverage monopoly power. So we know that in this vertical industry, the supplier has a monopoly upstream and can actually use that monopoly upstream already to earn or to extract all the monopoly rents, all the monopoly profits, even if it deals with all the retailers. It just makes sure that its good, its monopoly good, is supplied at monopoly quantities to these downstream firms, and that will create the make sure that the monopoly result will be the final result in markets, and will create those rents actually that it can then extract. And even if this firm then merges with a downstream retail firm, well, it already has all the monopoly power and all the monopoly rents that it owns. So how could it actually create more rents? All the monopoly power that exists by virtue of its upstream monopoly position, it could already extract, even though this downstream layer in the industry was already competitive. And moreover, it might even be that there is harm to this firm if it's going to exclude some of these downstream retailers, in particular the ones that it's not integrated with, because perhaps these other downstream retailers are to some extent differentiated, and if you don't use those supply channels, those retailing channels, to reach your consumers, you're actually going to harm your own profit. So there's actually not such a big concern for exporting, for leveraging your upstream monopoly power downstream, and it's going to be harmful for these firms to exclude some potentially efficient channels towards consumers in the downstream industry. And the catchphrase here, actually, that was coined by these Chicago School scholars was, well, there is just a single monopoly profit in this whole supply chain, and this single monopoly profit is already realized because this firm already has a monopoly position at some point in this supply chain, in this instance in the upstream part of that supply chain. So if we do see parties, upstream and downstream firms, that decide to integrate, well, in that case, it's not for monopoly reasons, it's not for market power reasons. There must be some other benefits, and those benefits will typically be those pro-competitive benefits that we spoke about. So in the absence of the leverage of monopoly power, probably it's a good thing to allow firms to merge. And indeed, these Chicago School scholars were very influential, and the response to this critique in the 1970s, and particularly in the 1980s, there resulted in a much more permissive attitude also on the part of the regulators and competition authorities towards these vertical mergers. Much was allowed. Now, there was a backlash, if you wish, or a response to this, which is called post-Chicago economics. So people, of course, understood and saw some reason, of course, in these Chicago arguments. But the 1980s and also starting in the 1970s and continuing even after the 1980s, there was a large increase in the importance of game theory. So game theory was introduced in industrial organization, and this led basically to game theory motivated arguments for why perhaps there might be some concerns after all. And one of the most prominent papers here was a paper by Oliver Hart and Hart-Tirole. So later on, they actually, both of these got separate Nobel Prizes a couple of years ago, actually not very long ago, for their work, among other things, on the theories of the firm, theories of market power. But what in this 1990 paper, actually Hart and Tirole claimed or proved actually was that, yeah, there might be a problem after all, namely there might be a commitment problem. So this monopolist, this upstream guy, let's call this firm U for upstream, may in reality in this setting actually suffer from a commitment problem. A commitment problem that actually, without integration, does not allow this upstream monopolist to actually capture all its monopoly rents. And if we then see vertical integration, that might actually be a way for this foreclosure as a result, actually, that might be a way in which this upstream firm might actually not raise its profits beyond the monopoly profits that it might get, but actually to allow this monopolist to restore its monopoly position. So that's basically the type of model, the rationale for the model that we're now going to discuss. So the idea again is we have this upstream monopolist, so the supplier or firm U, the upstream firm, and we have these two retailers, and there's no vertical integration here. So let's ask, what's the market outcome here? So this supplier, of course, is going to negotiate contracts with retailer 1 and with retailer 2, and then those two retailers will be selling to end users in the consumer market. Well, let's figure out what the equilibrium in this market is going to be. So what the setup of this model, well, it's all described in the chapter by Rij and Tirole that you have, in particular in section 2 of that chapter. So do read that to complement this lecture. So the setup of this model is as follows. So first of all, this upstream supplier, so let's call him indeed U for upstream. And this upstream supplier is producing some good, and the marginal cost of production is C. And then there are these two downstream retailers, let's call them D1 and D2, so downstream firm 1 and downstream firm 2, who are indeed selling to these end users, and there's some inverse demand function here, P of Q, which is going to depend on the total quantity that's going to be offered by these two downstream firms to consumers. So what's the game now? Well, the game is that the timing of this game is as follows. In the first time step, this upstream firm, this supplier, is going to make contract offers to these retailers, to D1 and D2. So what are these offers? Well, the company U, the supplier, is going to say to D1, well, here is a quantity Q1 that I'm going to offer to you that you can buy, and the total amount of money that you have to pay in order to buy this is going to be F1. So it's not a per unit price, it's just the total fee. So Q1 and F1 will be the contract that will be offered to firm D1, and likewise U is also going to make an offer to firm D2, to the second retailer, which consists of a quantity of goods Q2. So you can, I will sell to you a quantity Q2, and in exchange for that you will pay me an amount of money F2. So this firm U is a monopolist, so it can make take it or leave it offers to these two retailers, meaning you can either accept this offer or reject it, and then if you reject it, there's just no contract, it won't do any business, and if you accept it, you get the Q1, you can sell it to end users, and you pay the F1, the amount of money, to me. And if you note, we discussed this a bit earlier, so these kinds of contracts where we just say what the amount of quantity is and the amount of money that will be paid in response to getting this this amount of money, those are called quantity forcing contracts. So what happens then? Well, these D1 and D2, these two retailers there, can say, well, I'm going to either accept or I'm going to reject those offers. So that happens, that's phase 2. So they have either accepted or rejected, or one might have accepted and the other not, what have you. And then in stage 3, supposing that well, both have accepted, which is hopefully is going to be the equilibrium here, they will both sell their quantities to end users in the market, to end consumers in the market. It will generate some price, and price will be the P, which is a function of the sum of the total quantity that's produced in this market, so Q1 plus Q2, because these two firms are selling the homogeneous good to the same consumers. And indeed, these two firms realize their profits and these prices, and they pay the amount of money F1 and F2 to the upstream firm. So let me draw this in the picture for you. So let me do that on paper then, of course. So here we are. We have the firm U, the upstream firm. It's dealing with these two retailers, D1 and D2. It's offering these contracts, so it's saying to D1, listen, I'm offering you Q1, I'm offering to company 2 Q2, and in return for that offer, you will pay me F1 and you will pay me F2. So those are the contracts, and the D1 and D2 observe what their contracts are, what their offers are, and they can say, oh yeah, that sounds like a good deal, and I accept that, or they might also say, no, wait a minute, I'm not going to accept this. So let's think about, what is the profits? What are the profits that each of these players are going to make? Well, of course, this upstream firm, what will its profits be? Well, it's going to get money. It's going to get those payments F1 and F2, because that's what these firms, if they accept the offers, are going to pay to this to the upstream firm. And in return, the upstream firm has to produce the good. So it has to produce Q1 for downstream firm for retailer 1, and it has to produce Q2 for downstream firm 2. So the total profits that this firm is going to make is, well, the money it gets from firm 1, from D1, minus the cost of producing for D1, which is C times Q1. So C was the cost of manufacturing this good, and same for to also get money F2 from firm 2, minus the cost of producing that amount of goods for firm 2. So that's the upstream firm's profits. So what's firm D1, so the downstream retailer, the first downstream retailer's profits? Well, it's going to sell in the market. So what will their profits be from selling in the market? Well, it depends on what the price is. The price is P, which is a function of Q1 plus Q2, so the price is a function of total quantity times the amount of quantity that firm 1 is selling into this market, so that's its income. what does it have to pay? Well, there's no, I didn't assume no costs, no retailing costs, but the only costs are, well, I have to pay this bank of money F1 to firm U, so minus F1. And likewise for firm 2, downstream firm 2, it's going to sell its goods in the market for end consumers. So price again is this, multiplied by the amount of goods Q2 that it has at its disposal to sell to end users, and it will have to pay this agreed sum F2 to the upstream firm. Okay, so now let's ask what is the total profits that these firms make jointly. So what's the joint profits of these three firms? Joint profits of U, D1 and D2, we call that capital Pi. That's the sum of the individual profits, sum of the upstream firm's profits, plus downstream firm 1's profits, plus downstream firm 2's profits. So if I add those up, then you can of course see that these F1's and these F2's, they are going to cancel, right? They are just transfers, if you wish. They shift money from one firm to the other firm, but in total, on net, basically there is no effect of these, so they cancel out. So what do we have? Well, we have the income from consumers, so the income that's realized through firm 1, plus the income that's realized from firm 2. So it's this term here plus similar term from the second firm. So it's the price times the total quantity. And now what do we have in addition? The total costs that firm U is incurring for producing these goods, and that's of course minus C times Q1 plus Q2. So depending on what Q1 and Q2 will be, this will be the total profits that will be generated in this market. So now you might ask, well, this upstream monopolist is a monopolist, so by this Chicago School argument, it should be able to actually capture this entire monopolist profit in the market. And this is precisely that entire profit. So how should it, what kinds of contracts should we expect this U firm to offer? Well, such contracts that the total quantity that's sold in the market, so the total profits that generated through this whole chain of upstream and downstream firms is maximized. So basically what we would expect this upstream firm to do is to choose its Q1 and Q2 that it offers to this downstream firm in such a way to maximize the total profits that are generated from consumers, basically in this supply chain. It should be maximized, meaning that Q1 plus Q2 together should equal the monopoly quantity. So the best thing that you can do is to make sure that the aggregate quantity that's sold into the market through those two channels, through D1 and D2, is equal to the monopoly quantity. And then of course the price in the end for the end users is going to be the monopoly price. The total profit realized by these three firms together is going to be the monopoly profit for this market. And then the F1 and the F2 can be used to shift some of the profits that's going to be made downstream back towards this upstream firm so it can benefit from its entire monopoly power. So what does that mean? Well, of course, there's multiple solutions here, so there's multiple potential equilibria that we should look at. Of course, in each of these potential equilibria, we want to make sure that Q1 plus Q2 is this total monopoly quantity, but we can divide it in any way that we want. So one example might be, so Q1 is half of the monopoly and Q2 is half of the monopoly. So both firms will serve half of the monopoly quantity, so the entire market is served by the entire monopoly quantity. Price will be in the market will be the entire, of course, the monopoly price as it should be. And of course, this upstream firm having market power, it will set, apart from these quantities, it will set these fees, F1 and F2, to actually extract all the profits that are going to be made by these downstream firms, to extract those and to actually get paid back those amounts to benefit from it. So F1 will actually in that case be equal to half times the monopoly income, call this P monopoly times Q monopoly. And likewise F2 is also going to be half of the monopoly income. And indeed all these two downstream firms which are competitive are actually making zero, and all the monopoly profits ends up in the pockets of the upstream guy. So that's one solution. Of course there's other solutions. So the upstream firm might also decide, oh well, I don't need to be symmetric here, so I can also have a solution. I could decide to sell all monopoly quantity to firm 1 and nothing to firm 2. That's also one. And then any other distribution might do as well. In this case F1 will be the entire monopoly income, F2 of course will be 0. So those are two different kinds of solutions. Of course there's many more, as long as the quantities add up. Okay, so let's go back. So there we are. So here we see indeed again this total profits that could be made jointly by these three firms. So in accordance with the Chicago outcome, this profits will be maximized when the upstream firm, this monopolist firm, is going to make sure that total quantities add up to the total monopoly quantity for the entire market, and then these F1 and F2, these transfers, these fixed fees, they will be used to transfer all that money, all that income, the monopoly income, towards this monopolist firm U, the upstream firms. And as I mentioned, there might be different ways in which this can be done. So one is by selling half to each firm, so it will be symmetric outcome. Or another one might be to sell everything to D1 and nothing to D2, and any other split will do as well. So that's Chicago outcome. This upstream firm has monopoly power. It can actually make sure that the entire monopoly outcome is realized. Now what Hart-Tirole remarked was, if you look at this is like an obvious solution, but it's in fact not correct. It's not consistent with game theory and under a particular set of assumptions. And a particular set of assumptions is that these contracts, these Q1 and F1 and for the one firm and the Q2 for the F2 for the other firm, are actually not observable to the other guy. So in particular, D2 cannot observe what contract D1 gets offered, and likewise downstream firm 1, retailer 1, cannot observe the contract offer to firm D2. So those are called secret contracts. So as long as these contracts are not directly observable, this will actually not be the market equilibrium. So what might go wrong? So the idea that lies behind this model is, in this model, if these contract offers are secret, then if you get a certain offer, you have to be careful that this monopolist might have an incentive to actually rip you off, to cheat on you. So take as this example, let's look at this latter case in which one firm, in particular D1, is going to be offered to sell the whole monopoly quantity. So Q monopoly will be offered to firm 1, and of course the fixed fee, this F, this transfer, is the total income basically from monopoly that's going to be charged from D1, and D2 is in this hypothetical offer is not offered a thing, so it gets Q2 contract offer of 0. So suppose you're D1, you say, oh yeah, sure, I make nothing, but I can hardly expect to do much more than that. So if you leave me €1, then I'll accept that offer because it's better than getting nothing. So suppose D1 actually accepts this offer because it's marginally better than having nothing. Now D1, this firm that accepted this offer, should be worried. Why? Well, it could have assumed in this hypothetical offer that D2 gets no offer, but is that in fact something which is likely? Well, no, it's not likely, because this U can in that case actually do better for himself by also selling something, a positive quantity, to firm D2. So if you're retailer 1 and you have accepted this offer for selling the whole monopoly quantity, you are actually not completely sure that this upstream firm is not also going to supply some additional goods, some additional quantity to firm 2. What would happen in that case? Well, you've promised to pay the whole amount F1, the whole profits that you expect to make at the monopoly price, but now all of a sudden retail firm 2 is also going to sell something into this market, lowering price below the monopoly price because it's expanding the total output that's available in the market. So you are actually going to make a loss if it turns out that D2 is actually going to sell some additional goods into the market. So does this upstream firm has any incentive to offer any additional quantity to this firm 2? Yeah, it does, because taking as given that the monopoly quantity against the monopoly fee is already offered to the first firm, it can actually make some additional money by, well, for instance, adding a slight amount of quantity to this market, lowering price, but price is still close enough to the monopoly prices to actually make a positive margin on any additional sales that it will make through firm D2. So there's an incentive here for firm U to actually also go back to firm 2, to the retail firm 2, to say, well, yes, I know the total monopoly is already sold in the market, but I already got the money, essentially. I've contracted for the money, the F1, the total monopoly profits from retail firm 1. So firm 2, I'm going to sell a little bit extra for you to cheat on this other guy, but you can make some additional profits here because the price is actually way above the marginal cost. So in that case, actually D1 will actually make a loss, right? So price will drop below the monopoly price, and actually the total funds, the total fee that this firm 1 is going to pay to the upstream firm will be actually more than what D1 is actually making on those retail consumers. So if you know this, so if you know that you might be ripped off essentially, so if you accept this contract, you know that you will have an incentive to essentially to flood the market, so to create oversupply on this market by also selling something at a positive margin to firm D2, then you will actually not accept that contract, right? You will be a bit careful about accepting just any contract. So this will actually not be in equilibrium. So might there be any of these other contracts? So we could also split up the total amount. So for instance, each of these 2 retail firms each producing each buying half of the monopoly quantities, but still the same argument will actually go. The same argument will hold that it will remain profitable for the upstream firm to secretly offer to your rival to sell a little bit more extra. And for the rival, the same argument goes. So neither of these retail firms should feel very comfortable if they get an offer which presumes that they're going to sell the monopoly quantity into the market. So you might wonder, if that's not the equilibrium, then what is the equilibrium? So let's have a look at that. So the idea here is that what's going on here with these secret contracts is that this upstream firm is bargaining separately with these 2 retail firms. So it's bargaining with D1 over the contract for D1, and it's also bargaining with D2 for the total quantity and total fee charged to firm D2. And in each of these bargaining situations, what's going to be done, we have been looking at bilateral bargaining. What do you want to do? Well, you want to maximize your joint profits. So the 2 parties that are sitting on the negotiation table, they have the incentive to find a quantity that's going to be best for them together. Because if I can increase our joint profits, bilateral profits, then we have more money on the table, so we can always shift this extra money around so that both of us get better. So Q1 in particular, the quantity that U is going to offer to retail firm 1, that's going to maximize the price that we will expect in equilibrium times that quantity. So that's what this firm is going to make in equilibrium on consumers, minus the cost of producing that extra quantity C times Q1. And then F1 indeed is chosen to redistribute your profits. How? Well, in particular to the player here, the upstream player who has all the market power and who makes these take it or leave it offers. So now we see, of course, and that's the root of all these problems, this price, we don't know that beforehand. To have an idea, if you want to have an idea whether you want to reject or accept this contract, if you're a downstream firm 1, you need to form some kind of a belief on what Q2 is going to be, because that's going to drive what I, downstream firm 1, am going to make later on when I'm going to sell my goods to consumers. So I need to have some belief. What is this belief? Well, belief, that's something you learn in game theory, in perfect Bayesian equilibriums. These beliefs should be correct. So in the equilibrium, those beliefs of players should coincide with what happens actually in the equilibrium. So that's the idea of perfect Bayesian equilibrium. So D1's belief should be such that indeed the belief on Q2, so on the quantity that's going to be offered to retail firm 2, should be such that indeed it will be borne out in reality. And D1 will actually know that while U and D2, U and retail firm 2, they will actually engage in negotiations. They will also maximize their joint profits. So I better assume that when they are doing their maximization problem or their negotiation, they will also try to maximize their joint profits by choosing Q2 to be the best response to the Q1 that I will be getting in equilibrium. So in addition to this, what's happened on the equilibrium, if you wish, or what's going to happen in the equilibrium, so apart from this belief being correct in equilibrium, I also have to specify, if I specify some perfect Bayesian equilibrium, I also have to specify what's going to happen out of equilibrium, and the technical thing that we specify here is something which is called passive beliefs. So if somehow firm D1, so the retail firm, gets an offer that it did not expect, so something which might happen out of the equilibrium, then the assumption is going to be you're not going to revise based on this weird offer that I might be getting. I'm not going to revise what I believed that my rival was getting, so the Q2 that would be offered to my rival. So that's basically the setup of this Bayesian equilibrium that we are basically considering here. So what's going to happen? Well, this upstream firm and this downstream firm, they are going to negotiate. So again, what are they going to negotiate on? Well, they're going to at least make sure that the quantity that they negotiate over will be such that's going to maximize their bilateral profits. So how much profits are they going to make together, the two of them? What's the total money, the total income that they will make in the market? So P as a function of Q1 plus Q2 times the quantity that they are selling together into the market to end consumers, minus the cost of producing the Q1. So these two players, U and D1, they are going to choose Q1 to maximize the total profits that they together will make. And likewise, U and D2 are also going to negotiate, and likewise they're also going to choose their quantity in such a way to maximize their joint profits. So it's a separate negotiation table, if you wish. They will have an assumption, a belief again, on what Q1 will be, and they will choose their Q2 to be that quantity, which again is going to maximize, given that belief on Q1, the total profits made for their combination. So let's have a look at what this means. So let me again go back to paper. So what we want is to find the actual equilibrium. We want to, in each combination, we want to maximize the bilateral, the joint profits for the pair that's negotiating. So for the pair U plus D1, they're maximizing their total profits. They want to maximize, they want to choose Q1 to maximize P as a function of Q1 plus Q2 star times Q1 minus C times Q1. And what this star basically means, this is the belief that a particular firm D1 will have on what Q2 is, and it will be actually be the equilibrium value, right? So this belief is rational, so it will coincide with what will happen in equilibrium. So Q2 star will be the equilibrium value that D1 understands will be the outcome of this game. And likewise, U plus D2, they are negotiating. And they are negotiating to maximize their joint profits, and they together will take as a belief the amount that's offered to firm 1. So D2 again, it does not observe what's offered to firm D1, but it does know that it does have a belief, and this belief again will be the Q1 that will be realized in the equilibrium. So this will again be the equilibrium Q1 minus C times Q2. So the question is, can we jointly maximize, on the one hand, the first expression here, on the second hand, the second expression, so the bilateral profit of U and D2, such that the outcomes of that maximization, so the Q1 and the Q2 that we see here, will be the same as those Q2 star, will define those Q2 star and the Q1 star over here. So it should be consistent, should be a rational belief. So now the question is does this seem like a problem that we've seen before? So think a little bit about this. We want to maximize to profit-like expressions, taking as given the production of the other set of firms. So Q2 star over here, Q1 star firm, taking as given as the equilibrium value of this other firm. And therefore we want to find the best response basically to that equilibrium value that's produced by the other group of firms. Do we recognize it? So you might pause the video, but let me go on then. Let me, if you have not found it yet, let me take an example actually. Take an example, then we will see what the outcome of that example is. For example, let's assume that this, I kept this general what this function P, this demand function is, but let's now take the example that P is linear demand. Actually, P is 1 minus Q1 minus Q2. And let's plug that in. So I want to maximize 1 minus Q1 minus Q2 star times Q1 minus C Q1, and likewise for the other one. So what do I need to do? So I need to write down the first order conditions. So I have two first order conditions. So for Q1, maximizing this thing, I will find the first order condition 1 minus 2Q1 minus Q2, so in equilibrium Q1 star minus Q2 star minus C equals 0. And the other first order condition for the second maximization will be 1 minus Q1 star minus 2Q2 star minus C equals 0. So these are the first order conditions that result if I take the linear demand P equals 1 minus Q1 minus Q2. What's the solution of this? Q1 star equals Q2 star equals 1 minus C divided by 3. So do we now recognize, or perhaps you already saw this coming, but do you recognize these expressions? I hope you do. These are standard Coulomb duopoly quantities. So the outcome of this maximization of each of these bilateral profits is going to be the Coulomb outcome rather than the monopoly outcome. So at that, let me go back to the slide. So do you recognize this problem? Yeah, indeed, these are exactly the Cournot duopoly quantities that are going to solve these two maximization problems. So the first question I asked, what's the best response Q1 in response to the equilibrium Q2, and simultaneously what's the best Q2 response to the optimal Q1? Well, the intersection of those is essentially precisely the Cournot equilibrium, as you know. So what have we learned here? The equilibrium, if these offers that are secret, that you cannot observe, but for which you have to form some kind of expectation, some kind of belief, and this belief has to be rational, so it has to coincide with what's going to happen in practice. The outcome of that is not monopoly quantities, but Cournot quantities. So if you, this upstream firm, the supplier, if it cannot commit to quantities, it cannot commit to saying, well, this is what I'm going to sell to your rival, and you can hold me to this quantity, and it can say to D2, well, this is how much I'm going to sell to Q1. You can actually count on that. If you cannot make such a commitment, then each retailer will assume that this upstream firm is going to act rationally, or to act opportunistically, if you wish. So it will make sure that it will sell the best response to the quantity it sells to you, and will sell that quantity to your rival. So you will not actually accept any contract that has the pretension that you will actually sell monopoly quantities, because you know that it's only duopoly quantities that are best responses to each other. Q1 and Q2 being best responses means that without this commitment you can only realize Cournot duopoly quantities. And as a result, of course, the upstream firm can only make the total Cournot duopoly profits from this market. It cannot actually realize total monopoly profits, can only realize duopoly profits. Well, all of this is, of course, assuming that you cannot commit. This upstream firm cannot make a commitment on how much it will actually sell to your rival. So you would like, if you are the upstream firm, you would like to make this commitment because you would like actually to gain the total monopoly profits rather than the duopoly profits, which are lower. So how could you commit? Well, of course, if there's many interactions here, at some point you get a reputation. So if you keep your total quantities low to the monopoly levels rather than let these quantities rise each time to the duopoly levels, then of course at some point these firms will understand that you have a reputation for selling only monopoly quantities. So that might be one reason why this works. So basically this commitment problem is going to be most serious, put differently, in markets in which there's not frequent interactions. It's just occasionally there will be large deals, and then a long time nothing will happen. Another way in which you could commit is actually by using either vertical restraints in your contracts or vertical integration. So how would that work? Well, let's look at the vertical restraints in the form of an exclusive contract. So what might work is if you bargain with D1, if you say, listen, I'm going to sell to you the total monopoly quantity, and I know you will be scared that I will also sell then to your rival and that you will actually make a loss, but let me also add this. Let me add this clause to your contract which says you will be the exclusive retailer that I will supply to. And if you see then any supplies to your rival, then you will know I've broken this contract and you can actually go to court. You can take me to court. So if you can write such an exclusive contract, that's actually D1 can use to go to a judge to uphold this contract, well then of course you have restored commitment power. So exclusive contracts will work to again bring back total quantities to the level of monopoly quantities, and to allows essentially the upstream firm to commit not to sell and to undercut basically prices by going to your rival as well. So exclusive contracts might be one way in which firms might be able to solve this commitment problem. An alternative solution is vertical integration. So you might imagine that indeed the upstream firm, the supplier U, is merging with downstream firm D1. Well, in this case, it's actually very credible not to sell to D2. So now the profits for D1 are actually internal to this merged entity. It's your own subsidiary that you will be cheating on, and well, that's not what you will be going to do. So you can actually reliably make the commitment here that you're only going to sell through your own subsidiary and keep from selling anything through this other downstream firm D2. So here you can actually, once you have internalized through vertical integration this whole profit channel through D1, you internalize that negative effect of selling to D2 as well, and that keeps you from actually breaking your promises. So in either case, of course, you get the equivalent outcome. All the monopoly quantity will be sold through channel D1, so through the retailer 1, either through this exclusive contract or through vertical integration. Okay, so to summarize what we have done so far, so we've seen there's this potential commitment problem. So without any further action, this upstream firm U might not actually be able to reap the total monopoly profits, because it will not be able to commit not to cheat on either of these retailers. But it can actually restore monopoly quantities by either engaging in vertical integration, by vertical merger, or by having some exclusive contract. So both of these mechanisms are basically ways to restore the total monopoly profits, a way raising it from duopoly profits to monopoly profits. So how does it then relate to this Chicago critique? So the Chicago critique said, well, you cannot leverage your monopoly power from the upstream to the downstream market. So you cannot make more than the total monopoly profits, total monopoly industry profits from this monopoly position that you have upstream. And of course, there is a single monopoly profit. And Hart-Tirole said, yeah, that's right. There is a single monopoly profit, but you cannot actually make this single monopoly profit. You are sort of condemned to always lose something because of this commitment problem, unless you actually engage in either these vertical restraints or in this vertical mergers. So rather than raising your profits above monopoly profits, vertical merger allows you to restore your total monopoly profits. So here we actually looked so far at a model in which these two retailers are producing homogeneous goods. What is interesting and what we're going to look at in the tutorial session is what happens if these firms are actually differentiated. So they are selling substitutes but not complete substitutes. So they have they're imperfect substitutes. So they might have a slightly different location, for instance, in which they're selling, or a slightly different brand that's attached to this from the retailer. That's going to add some additional value. Again, we might want to look at what's the monopoly benchmark. So that's now not just Q1 plus Q2 that's going to be determining what prices are, but prices might be different in market 1 and in market 2, and they will depend on separately Q1 and on Q2. So again, we might wonder, what's going to be the monopoly benchmark, and then again we'll realize, well, that monopoly benchmark might not be realizable. So again, we have this commitment problem. And what we'll do is we'll have a look at how does this play out in a particular example, again, of linear demand, but now not with a 1 over here, but with some alpha, which might be below 1. So this alpha is then, of course, going to measure to what extent these two goods are substitutes or not complete substitutes. And what we will do in that case is to compare the no commitment equilibrium, so if you wish the Cournot equilibrium in terms of quantities, with what happens if you do allow vertical integration or if you do allow exclusive contracts. And now there's going to be, you will find that it will not be possible actually to completely restore profits towards monopoly profits, because you will actually need both of these firms to also capture basically this more advantageous location of the other guy, basically of the other retailer, or the different brand of the other retailer and the value that's attached to that. So have a look at that in the exercise. So let me wrap then up the topics that we discussed today. So we looked at vertical mergers. So compared to horizontal mergers, certainly market power is less of a problem. So of course efficiency gains might play a much stronger role here. So we looked a little bit at this double marginalization, for instance, or at the internalization of externalities. But there might still be a potential concern, particularly if one of these firms has a dominant position, so some market power. There might be a potential concern about foreclosure, particularly if we've been looking at input foreclosure by a dominant upstream firm. So in terms of this foreclosure, we first looked at the Chicago School critique. So there cannot be any leverage of monopoly power, was their argument. There is already monopoly power, you can just extract it, use it. So if we see a merger, well, that's probably then a response to some efficiency gain, so no problems there. And then Hart-Tirole pointed out, well, might be a bit more subtle here. There might be this commitment problem, and integration can actually be a way to restore monopoly power. So there might, after all, be problems with vertical integration in these circumstances, or with exclusive contracts if vertical integration is not possible. So next week we will look at a variant of this, and the variant is going to be customer foreclosure. So it will be basically the other way around. Can we sometimes foreclose entry to the market for upstream, potential competing upstream suppliers? So that will be the topic of next week. So I'll see you then.